Hi, this is Physics 1, Chapter 2, the Projectile Motion, Part 2. And I left off with these next two problems I was going to get into with projectile motion. Now, one thing you need to remember with these is it takes some work. Even if I was to go through and figure this out, it's not something I can do in my head. I mean, each part takes some work getting through. You have to set up equations. I noticed even when I was first taking this physics back in my senior year of high school, it was a lot of work I didn't want to do, with senioritis and all that. This is, though, extremely important to do the work to set up the equations because you can't do it otherwise. So I've seen this with students. They want to just multiply two numbers and write that down as the answer, and that's not ever going to be the right answer. And you might as well just say, hey, I want a 0, because you're not doing it. So I'm going to look at two of them. One's going to be horizontal projectile, meaning the velocity is shot horizontally, and the other one's going to be at an angle. So with this, we have a rifle. We're shooting the rifle with 200 meters per second muzzle velocity. So I'm just going to do it this way. Here's your velocity, initial velocity 200 meters per second. And it shot a horizontal distance of 1.5 meters off the ground. How far does the bullet travel before it hits the ground? What speed does the bullet hit the ground? Okay, so with this starting, I'm going to set my 0, 0 at the gun, and I'll call down positive. So it's going off and it'll come and hit the ground. So this makes x sub 0 equals 0, makes y sub 0 equals 0, because I'm setting my 0, 0 up here. It makes y equal to this distance, and x equal to this. Now we don't know what x is. We do know what y is. It's 1.5 meters off the ground. So 1.5. Now we do know what the angle is. The angle is 0 since it's horizontal. That means cosine of 0 is 1, sine of 0 is 0. So v sub x, sub 0x, is the 200 cosine 0, which is 200, and v sub 0y is 200 sine 0, which is 0. Okay, and we can just visually look and say, okay, well, this is horizontal and not vertical at all. So v sub 0x is 200, v sub 0y is 0. The ay is 9.8, and it's going to be positive. And then ax is always 0. That's why we'll leave it out pretty much. And then we don't know the time, and we're not given anything else. What we're wanting to find is your distance, and then we're wanting to find the speed. So let's start with our x equation. X equals x sub 0 plus v sub 0 x times time. X sub 0 is 0, so I don't need to care about that. V sub 0 x is 200, so this becomes 200t equals x. Now we don't know what t is, we don't know what x is, so we're going to stop there. Y equals y sub 0 plus v sub 0 y times time plus 1/2 gt squared. Y is 1.5, y sub 0 is 0, v sub 0y is 0, so it's 1/2 gt squared. The only thing we don't know here is t, so we can get t here. So 3 equals gt squared. So t equals square root 3 over 9.8. You get 0.55. 0.55. And then we come over here, 200 times 0.55 for the time. And we get 110. .66. Right, so at time 0.55, this bullet has gotten down to 1.5 meters and has went 110 meters across. Right, so that's the first part of this. Next, they want to know what's the speed. What speed does the bullet hit the ground? Now, whenever they ask for a speed, or even if they ask for a velocity, just be on the safe side, include your angle, find this angle as well. And so to know what that, you're looking at this Vx, I'm sorry, that's a Vy, this Vx, and so the angle here is going to be equal to the angle here, right? So whatever this angle is, so we can think about this as just a Vx, Vy, velocity for V, and so we can get the angle and we can get the whole velocity through trigonometry. First we gotta get Vx and Vy. Vx is easy. It doesn't change. So we actually knew it from the beginning, it's 200. Okay, since Vx equals V initial Vx. Vy equals V sub 0 y plus gt. In this case that's 0, so V at y equals 9.8 times 0.55. You get 5.39. Okay, and then we can find our V, which is going to be square root 200 squared from your Vx plus 5.39 squared from your Vy. And you get 200.01. Okay, so because it's going down, gravity's acting on it, it speeds it up some. No, not a whole lot, but it does speed it up some. And then your angle, it's going to be inverse tangent Vy over Vx. So inverse tangent of 5.39 over 200. Sorry, I'm in radians. No, I'm just going to make sure of that. .54. So 1.5 degrees. Okay, and this is going to be below positive x-axis. Okay, and so that would be your your angle here, your velocity at the end of this will be 200 when it hits the ground. So basically it coming in at 1.5 degrees and hits the ground at 200.1 meters per second. And it happens in 0.55 seconds. Right, so let's do the next problem. Check the time. Okay. And it should take about 10 minutes to do these problems. Here a ball is tossed 30 degrees above our x-axis. So it's going to make a parabola as it goes. It's 30 degrees above. The ground at a velocity of 12 meters per second. Find the max height of the ball. Find the horizontal distance at the ball of the max height. So I say this is the max height. Alright, up here, max height. And then they're wanting this distance. Okay, so first thing we gotta do is break this initial velocity up into its components. So it's going to be 30 cosine, I'm sorry, not 30, 12. 12 is the velocity. 12 cosine 30, 12 sine 30. I'm going to set my origin here at 0, 0. So x sub 0 equals 0, y sub 0 equals 0. My a sub x equals 0, my a sub y equals negative g. I'm going to make down negative since everything is going up. Okay. Now, one of the key things here is your y sub 0, your vy has to be equal to 0. That happens here at the max height. Assuming that's the max height. I know it's not drawn perfectly, but at your max height, your v sub y equals 0. And your v sub x is just going to equal v sub 0x. That, again, this will always be true for a projectile motion. So we can look at our x equation. X equals x sub 0 plus v sub 0 x times time. And so we don't know what x is. We know this is going to be 0. V sub 0x is 12 cosine 30. And then this is multiplied by time. We just don't know what time is. So let's go to the y equation. Y sub 0 plus v sub 0 y times time minus 1/2 gt squared. Y sub 0 is 0. V sub 0 y is going to be 12 sine 30 time minus 1/2 gt squared. And then this y we don't know. So again, we don't know the time, we don't know the y. So this is where the velocity equations come in, or the one velocity. V sub y equals v sub 0 y minus gt. This we do know. It's going to be 0. So 0 equals v sub 0 y minus gt. So gt equals v sub 0 y. So t equals v sub 0 y over g, which is going to be 12 sine 30, which we have a number. That is a number over g. That's your time. So let's find the time. Time is 0.61. And so x is going to be equal to 12 cosine 30 times 0.61. So we'll just multiply this by 12 and multiply this by cosine 30. Maybe 6.63. 6.36, sorry. All right, now be meters. All right, so this is in seconds. That's in meters. So at this point, that's how far this has went. Okay, now, since this is symmetrical, well, we can say that the time to land is 0.6 times 2, 0.61 times 2, which the time to land is 1.22. And then the distance here, we put in 1.22 times 12 cosine 30 is 12.67. So this is the x to land, upper land here, time to land. It's 12.68, which is pretty close to double that. All right, I rounded a little bit, so that's why it's a little bit off. But yeah, you just can double this at that point. That's only because this is even. Now, if it wasn't even, I'm going to show you what you would do to find the time to land. And this is where your y equation will come in. So if you're landing at the same height here, that means your y is 0 at this spot you land. So we can say, well, 0 equals 12 sine 30 t minus 1/2 t squared. And so we can find the time this way. Move the 1/2 over. Cancel a t. So you have 1/2 gt equals 12 sine 30. And then solve for t. So t equals 24 sine 30 over g. Which gives me the 1.244. And then if I times that again by 12 cosine 30, I get 1.23, which, is more, I mean, this is specifically double that. This was rounded. So that would be how you would do it. Now, if you can do it this way, obviously, if it's leveled and it's not, the algebra is not too bad, but doubling it also works. I am going to do a problem since we got some time here. Well, this won't be as easy. And I'm going to try to show you a workaround with this. Alright, so let's say we are firing a missile at a place that's higher up. Okay, and you want to fire this off at not a missile, but more like a cannonball or something. We're going to fire this off at 75 meters per second. And we'll fire it off at 65 degrees. And let me see here what we want. Let's say this height here is going to be 13.5 meters. Okay. And I think I might want to give anything else. And let's say we know we hit it, so we want to find the distance here. Okay, so let's go with what we know and where we want to start our coordinate system. Well, since we're firing down here at the lowest point, I'm just going to start my origin here at 0, 0. So my x sub 0 is 0, my y sub 0 is 0, my v sub 0 x is going to be 75 cosine 65. My v sub 0 y is going to be 75 sine 65. My a sub x is equal to 0, so my v sub x equals 75. Well, I'll just write it this way. V sub 0 x. So Vx equals V sub 0 x. My AY, I'm going to make down negative is a negative 9.8 or negative G. And I don't know my Vy. I don't know if it's going to be important for this right now. Maybe we can find it later. But we don't know that. And let's see. We do know Y. Y is going to be 13.5 meters. And we don't know X, and that's what we really want to find. Right, so let's start with the X equation. X equals X sub 0 plus V sub 0 X times time. This is 0. This is 75 cosine 65. We don't know time. We don't know X. Alright, so let's go to Y sub 0, or Y equation. Y equals Y sub 0 plus V sub 0 Y times time minus 1/2 GT squared. So Y we know is 13.5. Y sub 0 is 0. V sub 0y is 75 sine 65 t minus 1/2 gt squared. Now, if you notice this, one of the things to notice is if I move everything over to this side, which let me do that. That'll be positive, this would be negative, that would be positive still, and that would equal 0. We have a quadratic equation. So to solve this, we need the quadratic equation. We can do that, and we can get the time and then get the distance, and we'll be done. But before I do that, let's see. We don't know Vy. This will be 75 sine 65. That's your V sub y, V sub 0y minus g times t. Yeah, and we don't know the time here. So that's not going to be any help. We're going to have to bite the bullet on this, and we're going to have to do, I know you can do a workaround with the one-dimensional, but this doesn't seem to be that way. You could, but it's going to take a lot more steps. I'll just kind of tell you what I mean. If we set that equal to the highest point, or Vy equals 0, we can find the time to get up to that point. Find the height to that point, then subtract these two heights to find the distance this has to drop So we can set this up into different problems. It's going to be more complicated than that. So here, it's just easier. Solve for time. Do the quadratic equation. This is your A. This is your B. This is your C. So T is negative B plus or minus square root of B squared minus 4AC over 2A. So T is equal to, this is negative, so it'll be 75 sine 65 plus or minus square root 75 sine 65 squared minus 4 times A, which is 1/2 times 9.8 times C, which is 13.5. All over 2 times A, which is just going to end up being 9.8. Alright, so you got two answers. One of these times is going to be negative. The idea is if you say this can backfires and goes the opposite direction, that's how long it's going to be. So not only will it be negative, it will be very short because it's going to be like a quick, like, let me kind of draw this out. You're angling it this way. You shoot it off. It's going, there's a spot where it can come back and just hit this way and hit the x-axis. It'll be very small, very short. So you want the positive answer here. To make sure you get a positive answer, I mean, you know, since this is positive, if you add this, you'll end up with a positive answer. So this part of this should be higher than this. All right, so best way I would do it is start inside here. 75 sine 65, square that, then minus, and we'll see what we can break up here. 4 divided by 2 is 2, so 2 times 9.8 times 13.5. I'm supposed to put the times in, 13.5. And so you get that. Take the square root. And that's going to be this answer. And so we can do 75 sine 65 plus our answer divided by 9.8. And we're going to take 13.67 seconds. Alright, oops, I didn't mean to do that. If we had done it the other way, so let me just kind of backtrack here. So 75 sine 65 minus our answer. Now you do end up with a positive. I thought it would be negative, but it will be very low. So it's only going to be 0.2. It's odd that that ends up negative, but maybe how I set it up, it's just a dot. Interesting. So anyways, we got 13.67. That will be the final time. So now we just got to plug that in to get your x. So 13.67 times 75 cosine 65, and you get 433.3 meters. that comes from this. So x equals 75 cosine 65 times 13.67 equals 433.3 meters. Okay. So that is how you would do one that doesn't have the same angles, or I should say not the same levels, and it's an angle problem as well. Alright, so I know it's a little bit off script for the notes, but sometimes it's good. I leave enough white spots that I can do this. Okay, so the next chapter will be going into forces, which will really help kind of pull stuff together before we get into energy. And I'll see you then.